Section 14E, question number 2, page 357. The question asks us to find f prime of x from first principles given that f of x is, and for part A, 2x plus 5. So the limit definition of the derivative, or the derivative from first principles, is given by f prime of x equals the limit of f of x plus h minus f of x all over x plus h minus x as h approaches 0. So to keep correct form, we will continue to place the limit there, and we will then place, or substitute x with x plus h minus 2x plus 5 all over, and then the x minus x cancels, so we're just left with h. And then we can do a little bit of simplification here. 2x plus 2h plus 5 minus 2x minus 5 all over h, and the 2x minus 2x cancel, the 5 minus 5 cancel. We're still doing the limit as h approaches 0. And we're left with 2h over h. The h's will cancel out here, so we've got the limit of 2 as h approaches 0. Therefore, f prime of x equals 2. We'll move on to part B now, which is a little bit more involved. The function is x squared minus 3x. So again, the limit, f prime of x equals the limit of, and now this time I'll just go ahead and substitute the x plus h in for x in this case, minus x squared minus 3x all over, and I'll do the x plus h minus x, x's negative cancel, as h approaches 0. And then I'll do this simplification here, expansion, simplification. So I've got 8x squared plus 2xh plus h squared minus 3x minus 3h minus x squared plus 3x all over h. And then I'll just simplify what I can. X squared minus x squared, negative 3x plus 3x, and that looks to be about it for now. And then we haven't used that h equals 0 yet, so we'll just keep that there in limit for limit notation. So leave the 2xh plus h squared minus 3h all over h. We've got an h in each term, so we'll factor that out. And be left with 2x plus h minus 3. The h's simplify down here. And then we get 2x minus 3 plus h as h approaches 0. And therefore, when h equals 0, we substitute that in. We're left with f prime of x equal to 2x minus 3. And now we'll just proceed on to part C. Get rid of that. And question 2c, the function is a little bit more complicated still. Negative x squared plus 5x minus 3. F prime of x is the limit again, and now I'll just substitute x plus h in for the x's here. it's very important to keep this second part in brackets, because especially when we have a negative at the beginning of the function. And that limit as h approaches 0. And I've already cancelled out the x and minus x here. So now I'll just expand this out to do a little simplifying eventually. I'll leave that negative outside for now, just because I don't want to get too far ahead of myself. I can expand that 5 in because it's not as tricky. And I'll expand this negative in to this second bracket. And this is all over h. And then, again, the limit notation. Now I'll run this negative in here. Negative x squared minus 2xh minus h squared. And I'll leave the rest the same, plus 5x plus 5h minus 3 plus x squared minus 5x plus 3 all over h. And now I get to cancel out a bunch of things here, so negative x squared plus x squared, 5x minus 5x, negative 3 plus 3. So the terms that are remaining in the numerator all have h's in them, which is very convenient for this process. Negative 2xh minus h squared plus 5h all over h. I'll factor out the h from the numerator and be left with negative 2x plus 5 minus h all over h. I just switched those two spots here because it doesn't really make a difference. Just kind of cleans things up for the next line. Those h's we cancel. Still using the limit of, this time, negative 2x plus 5 minus h as h approaches 0. Now when we substitute in the 0 for h, we find that f prime of x equals negative 2x plus 5.